Uh, Hi, I'm Maciej Monturewicz, Director of Engineering, Head of Cloud Native Computing and Application Business Group in CodeLime.
And I'm Łukasz Romanowski, Engineering Manager in CodeLime, leading project for our customers and our group's internal R&D team.
Today, we will introduce you to the platform engineering and internal developer platform concept. Then we will present open source based internal minimum viable internal developer platform, how we built it, how it works, what are the benefits, and how we will be developing it further. After the presentation, we will be happy to answer your questions regarding either platform engineering or IDP that we built. So, to understand platform engineering, we need to look at the history. Before 2007, 2008, development and operations teams work separately. Developers were responsible for programming the applications, and when ready, they were handing the packaged binaries over to operations, who were responsible for deploying and running the application on production. It was bad, mainly because of the separation of knowledge and significant waiting time related to hands-out communication, prolonged diagnosing of issues. So DevOps emerged and combined the operations and development engineers in one team that solved the problem of the traditional approach, however, not for long. Together with the private and public cloud expansion and surfacing the myriads of software development tools like CI/CD pipeline tools, infrastructure orchestrations, databases, queues, etc., the cognitive load laying on DevOps team become overwhelming. Additionally, in the bigger organizations developing microservice-oriented applications, where each team could have slightly different tools and processes, maintaining easy and efficient DevOps culture become more and more challenging. And here platform engineering was born to keep the effectiveness of the initial DevOps teams and to reduce cognitive load for developers by the usage standardization of software development tools. Very simply speaking, platform engineering takes the responsibility for setting up, securing, and administrating of all mentioned earlier tools, while the full stack teams are active users of those tools. And how is it done? The answer is IDP. IDP, which is Internal Developer Platforms. So what is it actually? So first, platform engineers take all needed tools, like I mentioned before, configure them properly, ensure they are secure, up-to-date, and etc. Then, on top of those tools, they create an abstraction layer with a user-friendly interface, like web user interface or API. This is IDP, this user-friendly abstraction layer on top of the tools. In effect, development teams can come and self-service whatever services and tools they need without asking. So let's see how we approach to building IDP in the CodeLime.
Okay, so we initially did some research into platform engineering, and we basically can look at building IDP either from ground up or from existing platforms. So TVP here is a finished viable platform. So it is a minimal set of tools, APIs, documentation, processes that can be used or are used to simplify operations, improve productivity, streamline development, and generally limit the cognitive load mentioned by Maciej earlier for the full stack of streamlined teams, and move this cognitive load into the platform engineering teams. For TVP, we build generally IDP from scratch. We obviously can reuse existing components. We can start small, for example, even as a static page with documentation explaining exactly how we use different system could be considered a finished viable platform for your team, and then build iteratively on top of that. For a comparison, we can use different approach, platform as a service. Different platforms are available in the cloud. They have generic set of tools, services, functionalities available. They cover multiple use cases. The goal is to have as many customers as possible. It's possible to start projects quickly, as long as you are using defined by the platform processes and tools. If you need to use something specific to you, they have limited flexibility. And in the long run, this may incur some additional cost in the future, technological debt that you may pay due to service being defunctioned. To compare them, we can also define golden paths, something coming from platform engineering, which are recommended approaches and best practices that guide developers towards creating successful applications. With those golden paths, we can say that finished viable platform is like building golden paths from ground up, from scratch, and platform as a service is closer to choosing some golden paths from provided within the platform. Why we chose TVP approach and generally incremental approach to building our internal IDP. We do have many years of experience in software development in many projects and with many customers. We know about pre-existing tools, processes, and so on. We understand non-standard customization requirements and integrations that are needed for our customers. We also wanted to leverage the expertise we have from the DevOps teams that they gather during different projects, working with different customers, and they basically know how to build the golden paths I mentioned earlier. And not to forget about the fact that building something from scratch is the best way to extend the knowledge about the topic. Same goes with platform engineering. We wanted to extend our internal know-how. In general, choosing TVP approach and making sure that the architecture is modular means we can provide a customizable IDP that can then be used in many different projects for many different customers, leveraging already existing systems, tools, and processes. Next, for our internal development platform, we need to define scope of the project. We start with the functionality. Obviously, the project team needs to be able to create new project, migrate project, set up a dev environment, share knowledge, and run tests and build. Due to the fact that we didn't really target any specific customer, we decided to put some constraints on our internal project. We want to leverage open source software, mainly due to the cost effectiveness. We want to have the ability to reuse existing plugins and integrations. We want to also write our own custom plugins and integrations in case we will need to integrate something specific from our customer. Additionally, making sure that it is easy to switch between different components that can provide the same functionality like GitLab, GitHub, and Gerrit, or same functionality like CI/CD system, which is provided by GitLab or maybe Spinnaker. We want to also make sure that we can deploy our solution in different environments, in cloud, in on-prem, and in hybrid setups. By looking at those processes and activities that can be integrated into the platform, and also our constraints, a general concept of an IDP template was defined. We introduced general bootstrapping infrastructure, ephemeral environments, and local environments. General bootstrap infrastructure consists of internal developer platform, all the other systems that are used by the developers, like version control system, issue tracking, and also artifact management system. For our ephemeral environments, which we defined due to the fact that, generally speaking, we wanted to focus on cloud native microservices architecture. We wanted to make sure that it is easy to create and destroy staging environments, but also environments for testing or even demoing the application. And we define local environments separately to be able to manage this kind of environments and also possibly improve in the future on the development experience side of the internal development platform. Our concrete realization of our proof of concept was a bit simpler than the general idea. We use GitLab to cover multiple components defined earlier, like version control, CI/CD, code review, issue tracking, and so on. We also use Harbor for artifact management, as it supports or can be used as container registry or container cache. And we use Backstage as the internal developer portal, which is the user-friendly front door, the single point of access for developers to discover, learn, and interact with the functionality available in the IDP. For the ephemeral environments, we decided to use vClusters, which allow us to easily create and destroy virtual Kubernetes clusters. And the backbone or the solution on which each and every component is deployed, we decided to use Kubernetes. This is basically a backbone cluster that on which all the infrastructure is bootstrapped. This way we can support multiple mode of deployments, cloud, on-prem, hybrid. For our POC, we initially use Minikube, but then we move on to our on-prem Rancher cluster, Kubernetes cluster. We assume that everything will be running on-prem, but we also did some investigation into integrating this with a production environment in Google Cloud. Additionally, within the backbone Kubernetes cluster, we have set up GitLab build runners.
If I could just add, please notice that internal developer portal is not the same as internal developer platform. Portal is just this very nice user interface, while the platform is entire abstraction layer.
Yes, exactly. Although Backstage is more of a framework which covers internal developer portal, but also gives us a plugin infrastructure for integrating with all the other components.
Yes.
Now, moving on to our demo. We'll start from demoing bootstrapping infrastructure. Hopefully everything is eligible. We start by setting up Cert Manager. This is needed for TLS support. Everything we do is written within scripts, makefiles, documentation. Also, this video will probably be helpful for our team later on. Everything is deployed on this backbone Kubernetes cluster. Right now it's Rancher. We deploy GitLab. GitLab deployment takes some time, so everything is sped up significantly. Once everything is running, we can set up Backstage. SyncV cluster for ephemeral environments. And Harbor as our artifact management system. It's worth to check if everything is working correctly. GitLab, Harbor, Backstage. And then comes some manual steps that are needed. Configuration of the Harbor, creating separate project so that Harbor supports both works as a container registry for our project, but also as a cache for Docker Hub and Google's container registry. We configure GitLab. We need to allow importing projects, integrations, and webhooks, enabling Harbor integration with GitLab. Last but not least, we also need to create a token to configure GitLab runners. Next, we have a runner online. So now we can import a project. This is our demo project being imported. Initial deployment on the main branch as well. Images are stored in our container registry, Harbor. Our demo project is deployed and available in main staging environment. Now the project is being imported to the Backstage itself. Project was prepared earlier to allow for this. And now all the components that were configured within the project are visible within Backstage.
On the video, it went all smoothly. However, I a little bit know that it wasn't that easy and straightforward in real life. If you could tell us a little bit about.
Yeah, obviously it was
you get
sped up. That's one thing. So normally it would probably take a few hours, all of this. But at the same time, we did have or overcome some challenges with the whole setup with the IDP. Yeah, so the challenges we encountered, the first one we basically encountered was a problem with certificates. When we wanted to integrate Harbor with GitLab and with Backstage. The integrations require a communication channel that's encrypted, supporting TLS. So we needed to have a cert manager installed within our backbone cluster. Next, as I mentioned, we started with Minikube. Everyone was working with Minikube and in testing of the integrations and developing scripts and makefiles was done this way. But later we decided to try on-prem deployment. Rancher was used. We needed to decide how many nodes will be used, what will be CPU and memory configuration. Finding efficient configuration was basically not that easy. It took some time, some trial and error, and in the end, I think most important improvement was done when we switched from one storage backend to another one, which was more basically efficient, and then the overall performance of the IDP improved significantly. We also hit the problem of Docker Hub limits. It's quite known problem now, so the solution was pretty straightforward. Just use registry cache available from Harbor. And last but not least, Backstage itself was was a challenge, a powerful framework for building internal developer platforms. However, not all the plugins that are available are production ready. This means that we needed to do some due diligence and check if one or the other plugin is working. Sometimes it is necessary to basically write your own plugin to make sure that the integration is working correctly. Some changes in the Backstage are needed. Not everything is possible with the plugin via plugin in Backstage. So sometimes deeper knowledge of the Backstage itself, its architecture and basically code bases is required. Let's now move on to the second part of the demonstration, which is our demo project. We would like to show you how a possible introduction to the project for new developer would look like. We already have IDP bootstrapped previously. The project is also set up. It was migrated, this time from GitLab to GitLab. It's also possible to migrate from GitHub to GitLab and so on.
So maybe before you start, the one thing, this our Astronomy shop is based on the OpenTelemetry demo distributed by the OpenTelemetry. It's important to know because you will see the screens telling OpenTelemetry demo. Yeah, so this is our Astronomy shop.
Yeah. So first, we introduce new team member to our documentation, onboarding documentation. Then we basically start presenting features of Backstage and also integrations that we so far done for the Backstage. You can see in the Kubernetes tab access to the ephemeral environments, vClusters. There are staging environments for different branches. We are now seeing staging environment for main branch, how it looks like. The new team member can obviously access it and see the application in action. Then we have a list of all the components that are part of our solution, our application. Each component may have some relations defined, so we can see a graph of relations between different components.
Which is microservices, yes?
Yes, this is in general the demo project we use is a microservices application. For each service, in this case, we can access its pod on each and every cluster and logs also for this pod. For each service, we have documentation. So a new team member can review the documentation, access definition of the APIs. In this instance, this is gRPC API defined for communication. Moving back to the, let's say, main component, you can see all the subcomponents. So basically all the components within this project, this application, this system. In the GitLab tab, you can see all the information we can get from GitLab within Backstage, including pipelines, merge requests, issues. And now our new developer gets an initial task of changing background color, creates or edits in Web IDE style properly or according to requirements in the task. Creates a merge request, first creates a branch and then merge request. When the merge request is created and the branch as well, a pipeline is executed. Pipeline is right now in running stage. You can see the branch is different, not the main branch. It was successfully built. Within the pipeline, you can also access kubeconfig, which may be needed to troubleshoot the deployment within the ephemeral cluster. So it allows new team member to access the ephemeral cluster, but at the same time, he cannot access the backbone cluster. Here you can see that a new ephemeral cluster was created. This environment is accessible for our new team member. His change is also visible within his environment. So one part of his work was successful. Everything is green in the pipeline. I can now try to merge his solution, assuming that he got all the approvals. Now the pipeline is running for branch main. Now it's finished. You can see that it is on branch main, so we probably should expect change in the main environment. We access this environment, or at least access the application deployed on this environment. Yeah, and you can see this is the main environment with the change from our new team member. Okay, so just to recap, first video was about bootstrapping IDP environment where we deployed GitLab Harbor and Backstage. We used vClusters for ephemeral environments. Everything was configured and so on. We also migrated our demo project to new IDP environment. In the next video, we showcase new developers' first day at the job, or maybe the second day. He got familiar with the documentation and the functionalities of the internal developer platform used, its capabilities, and also how our project is set up, or at least how this demo project is set up within the Backstage, because it's only one of the ways it could be set up. He got an issue, did a change in the code, deployed the code to his own staging environment, but also integrated this change to the main branch, and it was quickly deployed also to the main staging environment.
Yes, so I hope you recognized how easy and fast it was for our hypothetical new developer to start effectively contributing to the project. So based on that, let me extract a business benefit of the implementation of platform engineering and internal developer platform in an organization. I divided those benefits into two categories from the organization perspective: internal and external. Internal ones are developers work more efficiently thanks to eliminated context switching and reduced cognitive load. The new developer had the documentation, had two tools to work on, and without knowledge about Kubernetes was able to contribute to the project. Waiting time in organization is reduced because tools and resources are available without asking external teams or without need for approvals. Organization gets a uniform way of accessing service repositories, documentation, and people behind them. A risk of introducing regression in the code is minimized due to the faster and more frequent deployment with efficient CI/CD. Those internal benefits lead to the external ones. First one is short time to market of the developed product, thanks to first and second internal one, efficient work of developers and reduced waiting time. Second external benefit is increased customer satisfaction, mainly thanks for the faster delivery with a better quality. In effect, all those benefits lead to the goal of organization, which is the revenue growth. And at the very end, we would like to say a few words regarding the future. Our IDP is really a minimum viable platform. However, we already have a roadmap to make it broad, forceful platform.
Yeah. So for starters, we would like to focus on extending what functionality is available from within Backstage. So it means more integrations with different tools, so that we can, for example, easily switch later on between GitLab and GitHub. But in general, the idea is to move as much as possible from specific systems to our components of the IDP to Backstage itself. So if necessary, we want to also implement our own integrations with the Backstage to make this happen. We are also thinking about project templates. What I mean by that is that we want to first figure out how to add components, reusable components for the projects running on the IDP and not the components of the IDP. So that development, for instance, of projects that require some kind of LLM-specific configurations, systems, maybe models, maybe libraries, are already in place. And the team that wants to build a project with LLM in mind does not have to worry about this part of the project and focus on business logic, or focus basically on the mainstream of the project. Same goes for instance, for Kafka, RabbitMQ, which are generally used in many situations and can easily be integrated within this kind of IDP and used within any new project that will be developed on the IDP. And same goes for databases. So we can set up PostgreSQL or a Mongo database with proper configuration, high availability configurations on the cluster, on the Kubernetes cluster, and this is knowledge that's available and not necessarily needed for each and every project that requires database. It can be just given as a feature of the IDP.
Application developed under the IDP and then underlying infrastructure needs to be observable. So advanced IDP should provide pre-configured logging and monitoring tools. Observability is also one of CodeLime's specialties. So naturally, our next planned features is to build in observability toolset. We plan to base it also on open source solutions like OpenTelemetry, Prometheus, Grafana, Jaguar, etc. Security is one of the key reasons companies invest in the platform engineering. So in the next phases of our toolkit development, we plan to enhance it with secrets management and built-in compliance and security scanners like SonarQube or Black Duck. AI is another strong CodeLime's competency. So obviously, we plan to enable AI chat support for our platform. Also, we are thinking about some AI supported facilities, making developers' life easier. Yeah, so it was our platform in action with the initial concept and plans for the future. Now it's time for you. If you have any questions regarding it or more generic platform engineering IDP concept, we are happy to answer.
We do have one question already from John. Why did you decide to use Harbor as an image registry? So initially, we didn't even use Harbor in our concrete realization of the idea of IDP template. We just relied on the registries available in the cloud. So this was Docker Hub and Google registry. In the end, first we hit the Docker Hub limit, and basically this forced us to figure out how to overcome this issue. And at the same time, once we found that the Harbor also covers internal image registry for our components, we decided to move from GitLab registry to Harbor, so basically that all containers used by the applications are stored within Harbor, whether they are built using our GitLab from our infrastructure or whether they are downloaded from the cloud and cached within Harbor. Any more questions?
Let's wait a few more seconds. Oh, we have another one.
Okay, another question. Have you considered virtual cluster solution other than vCluster? Honestly not. We considered different approaches to ephemeral environments because to solve this idea of virtual clusters within this backbone cluster, we can solve this on a different levels. One of the solution could be to use basically namespaces in Kubernetes and this way separate different deployments from each other. But in that situation, the isolation between the ephemeral environments would not be that easy, or even could not exist. On top of that, would have to exist something different. There are also other solutions available which support stricter separation between this virtual, not really clusters. But in the end, we decided to use ready-made solution, which is available, the vCluster, which separates completely each ephemeral environment, making sure that no application is accessible from another ephemeral environment, and also that those environments are easily accessible in a very similar way as in production, so that we can access those environments using kubeconfig, for example. So these ephemeral environments are pretty much one-to-one to production environments, which makes life easier for developers. Yeah, and another one. So the question is about switching from GitLab to GitHub. Yes, we are tightly integrated in the sense that GitLab covers multiple components of our initial idea. And I believe it should be pretty easy to switch to GitHub, although it will not be minutes or hours, but probably days to figure out how to integrate GitLab with Backstage. But all in all, there are more or less features that are now functionalities of GitLab that are visible from Backstage. Can be also similar functionalities can be made visible in the Backstage for GitHub itself. So not that much effort. More effort will be needed if we start to integrate different solutions for specific components like CI/CD systems. So if you wanted to drop using GitLab CI/CD, we'll need to check, for example, if Spinnaker is supported in the Backstage. If it is not, we'll probably need to write our own custom integration for the Spinnaker or any other CI/CD system we want to do. But as we said in the future direction, this is basically one of the directions, one of the activities we have in mind in the future.
Okay. Let's again give a couple more seconds. Maybe the last.
Yeah, I think that
Question.
was the last question.
Okay. So if you could please show the next slide. Yes. Oh, no. Okay, so thank you for showing up at the webinar, for listening and the questions. So let me use this opportunity to invite you already to our next webinar that will take place in a month on June 19th. It will be on leveraging network automation for operational efficiency and growth. So we will be happy to welcome you again. And regarding our webinar, please fill the survey you can find in Zoom. We will appreciate your feedback a lot. And thank you very much, and goodbye.
Thank you and goodbye.